We're all hurtling through space on this giant spinning rock, but we never actually feel it. So, have you ever stopped to wonder what would happen if that constant, fundamental motion just stopped? It's a classic thought experiment for sure, but the reality is way more intense than you might imagine. Okay, so this is probably the first question that pops into your head, right? If the planet just slams on the brakes, does our momentum just, I don't know, yeet us into orbit? It's a pretty cool idea, but the physics of it all tells a completely different story.
I mean, just look at these numbers. The difference is staggering. At the equator, where the spin is fastest, we're moving at a pretty wild 1,000 miles per hour. But to actually escape Earth's gravity, you'd need to be going 25 times faster than that. We're not even in the same ballpark.
So yeah, the answer is a big, fat nope. You would not be flung into space. Gravity's got way too tight a grip on us for that. But here's the thing. That's where the good news stops. The real problem isn't getting launched up, it's what happens sideways. And trust me, it's way, way worse.
Right, so let's get into this. The real danger is sideways, and it all comes down to one of the most basic laws of physics, a concept you actually deal with every single day: inertia.
Okay, so here's the big problem. In our crazy scenario, some unimaginable force stops the solid Earth in its tracks. But that force doesn't stop us. It doesn't stop the buildings, the oceans, or even the air. Basically, Newton's first law says all that stuff is going to keep right on moving.
It's kind of like this. Imagine you're in a car and you slam on the brakes. You lurch forward, right? Now, crank that up to an insane level. This isn't a car stopping at 60 miles an hour. This is the entire planet stopping from over 1,000 miles an hour. Everything on it instantly becomes a high-speed projectile. So here's the play-by-play of this absolute nightmare. 1, the planet stops. 2, everything on it keeps going. 3, we, and pretty much everything else, buildings, trees, even the topsoil, would get scoured clean from the surface, flung eastward at supersonic speeds.
And yeah, the outcome is, well, it's pretty gruesome. I love how one Reddit user put it, you'd be turned into anchovy paste. It's a horrible image, but it really gets the point across, right? We're talking a catastrophic planet-wide tumble.
And just when you thought it couldn't get any worse, it does. Because it's not just the stuff on the ground that has inertia. The very environment around us, the air and the water, would become the ultimate weapons.
The air itself, the entire atmosphere, has momentum too. It would keep racing eastward at up to 1,000 miles an hour. Look at this chart. We're talking about winds that make a Category 5 hurricane look like a gentle breeze. This isn't just a storm. It's a planet-wide sandblaster that would shred anything left standing.
And while that's happening, you've got another huge problem: the oceans. They carry an unbelievable amount of momentum, and they are not stopping with the land. They just keep on going. What you get is a global mega tsunami. I'm talking about walls of water, not feet, but hundreds of meters high, crashing over the continents. They wouldn't just wipe out the coasts, they'd surge for thousands of miles inland, literally redrawing the map of the world in a matter of minutes.
Okay, so let's just pretend for a second that something could survive that initial, total apocalypse. Well, the planet itself would start to change in some really fundamental ways. The world would never be the same again.
You might not know this, but Earth isn't a perfect ball. It's actually a little squished, with a bulge of land and water around the equator. That bulge exists because of its spin. So, what happens when the spin stops?
Well, gravity takes over completely. All that water at the equator would start to flow towards the poles, where gravity is now effectively strongest. And what you'd end up with is a world that looks completely different. 2 massive oceans at the poles, and 1 gigantic supercontinent wrapped all the way around the equator.
And to really bring this home, just look at what would be underwater. We're talking about almost all of Canada, most of Europe, gone. U.S. cities like Chicago and Boston, submerged. Antarctica would just vanish beneath a new, massive Southern Ocean.
Oh, and if all of that wasn't enough, here's the final nail in the coffin. Our planet's spin is what churns the liquid iron core, and that generates our magnetic field, our shield against deadly radiation from space. Without the spin, that shield would likely just fizzle out.
Okay, deep breath. After that fun little trip through total planetary destruction, let's pull back. It's a wild thought experiment for sure, but it's time to get back to reality and ground this whole thing in what's actually possible. So that leads to the big question, the one you're probably asking right now. After hearing about all this world-ending chaos, should we actually be worried? Could this really happen?
And I am very, very happy to report that the answer is a definitive no. It just can't. There's no force we know of in the universe that could just bring a planet to a dead stop like that. It would literally violate the laws of physics, specifically the conservation of angular momentum.
Now, it's true, the Earth is slowing down, but just barely. The moon's gravity is pulling on it, acting like a tiny brake. But look at the rate, 1.7 milliseconds per century. It's so incredibly slow that it poses absolutely no threat to us.
So what's the point of all this doom and gloom? It's really to show just how incredibly important our planet's rotation is. It's the engine that shapes our geography, protects us from radiation, and makes life possible. As this strangely perfect quote reminds us, our spinning world is what keeps everything going. The takeaway here isn't to be scared, but to just appreciate how finely tuned and, thankfully, how stable this amazing rock we call home really is.